Hey guys, I'm Nitesh and we are back with the Intro to Machine Learning series by ISTE. Today we'll be going ahead with support vector machine implementation part. So in the last video we talked about what is SVM, how does it work, what was the cost function, what was the loss function, how we will optimize this, and what if the data was not linearly separable and all of these things. In this video we will see the implementation for a linearly separable classification problem. So the first thing that we do is importing library. So here we have imported panda numpy, and there's another thing cborn, that is actually matplotlib library based GUI. That means a graphical based library that actually helps in visualizing the data, right? So I have imported cborn as SNS and I have set the font scale 1.5 and the rest of things you are aware of. Yeah, I executed this. This is the data which I have prepared on my own. So I'm just executing it. We'll see what are the data points. Data was defined in a dictionary, which had this was its key. These were the values that I passed as a list since it's going to be n dimensional. Yeah, and now with the help of Panda data frame, I actually converted into a data frame and defined as df equal to pandas dot data frame, and I passed this dictionary into this and got my data frame, and I'm printing the head. That means the first five rows will be printed. That is actually my the whole data set. For simply to keep the model simple, I have defined only five data points. Okay, so these are the 0 comma 0. These features are x1 x2 and the result is r. A is the class, so 0 comma is class A, 1 is class B, and all. So yeah, so these data points I have plotted, which will better instead of looking at this values. So with the SNS dot, that means cborn library dot lm plot, I'm passing the xy values, that means the feature values, and the data which I defined as df, and the hue, that means whatever it will show here, and the palette is set of the colors that I'm taking as set 1. You can even set it as set 2. Fit regression is false and scatter KWS is S50. That is about the grid line specification. Let's run this. Yeah, so we got this here. So this is the class B and this is class A. So yeah, you can think of this as our previous problem of credit worthy and not credit worthy, right? Let's move ahead. After plotting the graph from sklearn, we are importing SVM, that is support vector machine. So from sklearn.import SVM, we got support vector machine. Now define our the input array and the output array, that means input and label for training our model. So first of all, I have defined points, okay, as, and inside this I have taken data frame x1 and x2 values, right, and results as data frames result value, r value, right. So we execute it. So we have now two points and results. Now what we do, clf is svm. Clf is our model name. svm.svc, that is support vector classifier, that is actually svm for classification problem, and we have taken kernel equal to linear as this data is already linearly separable. And then we do clf.fit and the input, that is points, that is x1 and x2, and the results, that is the label. So now that's training our model. Since our model was too small, that is only 5 data points, so it got trained instantly. Now here the outputs you can look at your own. That's pretty much, you can go for the documentation. That's what I prefer. Now let's print the weights of the vector that we got after training. So here it's showing 0.4, 0.8. This is the weight vector, right? The bias is minus 2.2. This is the weight and bias associated with hyperplane, right? So we have the equation of hyperplane as wx plus b equals 0, right? Now let's clf dot support. This will show the indices of support vectors, that we will have two support vectors for both classes. If it was a like n dimensional thing, then we would have n support vectors, right? There is always one support vector corresponding to each class. So we had only two classes, therefore we got two support vectors. Now, if you want to print the support vectors, we can print them. That is the data point associated with the support vectors. We got it right. Yeah. Now the number of support vector for each class, it is 1 comma 1, but still we are gonna run this. Now the coefficient of support factor in the decision function, yep, we find it as np dot absolute clf dot dual coefficient for, yeah. Now uh, weight is obviously clf, that means model name dot coefficient 0. Slope is obviously whatever the weight we got, the first weight by second weight. That means if the line equation is ax plus by equals 0, so what was the slope? Obviously minus a by b, obviously the minus a by b. So similarly minus weight 0 by weight 1, right? So the now the bias is obviously the intercept we get. Now it's defined as CLF model name dot intercept 0. Now we define as XX, that is the input values for plotting the support vectors and the hyperplane. We are gonna input all the values of x. So we define as XX np dot line space 0 to 4, that it will feed all the continuous values from 0 to 4. So now let's run it. Now we'll define YY, that is the support, the hyperplane value. So the equation of hyperplane all will be equal to, if the equation of line is ax plus by plus c equals 0, then it's obviously going to be y equal to minus a by bx plus minus c by b. So we wrote it the same way. Y is slope into xx, whatever the input we have given, means the x values, minus bias by weight 1, right? The intercept, the coefficient of y divided by coefficient of y. So we got the y. Now s we defined as support vectors. Yeah, one of the support vectors we took as s, and now we wrote down the one of the support vectors equation, that is obviously y down equal to, uh, since the hyperplane and the support vectors are parallel, so it's obviously going the same slope, but the intercept will be changed. So we what we do, y down is slope into xx. Obviously the xx values will be the input values, and slope will define plus intercept. We can find intercept by using the other values. We already have got x and y values for the support vector s1 and s0, right, for the lower support vector. This is the lower support vectors y and x. So obviously y equal to mx plus c. So c we can find if it's already given y and x. So y minus mx. So this is s1, that is y minus slope into s0 x. So we got the intercept. This is how we got the equation for y down, that is the one of the support vector. We are executing it. Now similarly we can get the CLF dot support vectors, the other xy values for one support vector, that is minus 1, or you can keep it as 1 since this is the second support vector. Then we similarly define y up as slope x, and similarly found s1 minus slope into s0, the intercept, and we execute it. After, no, let's execute this. Okay, wait, I'm executing this, then executing this. Now I am just plotting the values. Okay, so sns dot plot x1 x2 data I given s7 I used this time. I also plotted xxyy line, xyy down, yy up, everything, right? So we'll see here what are those values. Okay. Yeah, so this is the hyperplane that actually divides your class A and class B, that's credit worthy not credit worthy. This was class B, and this is one of the support vector corresponding to class B, which is passing through one of the point. Similarly, for class A, there is a support vector corresponding to that class and passing through one of the marginal points, right? and this is our margin. Okay, yeah, that's pretty much it about the implementation part. Yeah, so we plotted. Yeah, apart from that, if we have trained a model, then we might be able to predict the output based on the data set. So you can see, if it was a 3 comma 3, then it's obviously that it would lie here, so it mostly should be class B, right? Let's run this. Print clf dot predict, we use for prediction, and we passed the value 33 comma 0, and we want the output. So we want comma 0, so we got the class B. Similarly, if you take 4 comma 0, so 4 comma 0 will obviously lie here, that is class A, so it will say class A. Same, the origin is already the trained data of A, so it will say A. Obviously the model is going to perform good at trained data and also untrained data. Yeah, so these are some of the examples you saw. So yeah, that's pretty much of the implementation, to keep it simple. So thank you guys for watching the video.